Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on ring theory, lecture number 10, in which I will give the details concept of Boolean ring. Now we define Boolean ring. A ring R with binary composition, addition and multiplication is said to be a Boolean ring if A be any element of a ring R, then A multiply A equal to A, that is A square equal to A. For all A belongs to ring R. In other words, if each element of a ring R with binary composition, addition and multiplication be idempotent, then R is said to be a Boolean ring. Example 1. Let S be a set containing elements A and B. PS be the power set of S. Therefore, PS contains elements empty set phi, set containing element A, set containing element B, set containing element A and B, and binary composition are addition and multiplication defined as let A B belong to PS, then A plus B equal to A minus B union B minus A, and A multiply B equal to A intersect B. Now A multiply A equal to A intersect A implies that A square equal to A intersect A is A for all A belongs to PS. Therefore, PS with binary composition, addition and multiplication is a Boolean ring. Here we see that A square equal to A for all A belongs to PS. Only for this property, this ring is a Boolean ring. Example 2. Let R be a ring which is Z2, contains elements 0 bar and 1 bar. Since 0 bar multiply 0 bar equal to 0 bar implies that 0 bar square equal to 0 bar. 1 bar multiply 1 bar equal to 1 bar implies that 1 bar square equal to 1 bar. Therefore, for any A belongs to Z2, A be element of Z2, we get here A square equal to A. Therefore, Z2 with binary composition, addition and multiplication is a Boolean ring. Now we solve a problem. Problem is prove that in a Boolean ring R, A plus A equal to 0 for all A belongs to R. Now we prove this. Let R with binary composition, addition and multiplication is a Boolean ring. Therefore, A belongs to R implies that A square equal to A. This is number 1. Since A belongs to ring R, therefore by closure property A plus A belongs to R, implies that if A plus A belongs to R, then A plus A whole square equal to A plus A. Here we have seen that A square equal to A if A belongs to R, ring R. This is equal to A plus A multiply A plus A equal to A plus A using distributive law. Since distributive law holds in ring, A plus A dot A plus A plus A dot A equal to A plus A. This is equal to A dot A distributive law plus A dot A plus A dot A plus A dot A equal to A plus A implies that this is A square. A square, A square, A square, A square equal to A plus A. Using 1, A square equal to A equal to A plus A. Using 1, by cancellation law, A and A cancel, left cancellation, this A and A cancel, implies that A plus A and right side remains 0 by cancellation law. And proved. We may conclude that in any Boolean ring R, A plus A equal to 0 for all A belongs to Boolean ring R. Therefore, any element A belongs to R Boolean ring is added twice gives 0 element. Therefore, characteristic of any Boolean ring is 2, because any element A is added twice, then we get the 0 element. So characteristic of a Boolean ring is 2. Now we solve the next problem. Next problem is, so that Boolean ring is commutative. Now we prove this. Solution. Let R with binary composition, addition and multiplication is a Boolean ring. Therefore, A square equal to A for all A belongs to R. Also, we know that in a Boolean ring, A plus A equal to 0 for all A belongs to Boolean ring. This is number 1. This is number 2. Let A, B belong to Boolean ring R. Then by closure property, A multiply B belongs to Boolean ring R. Since Boolean ring is a ring, so closure property for multiplication holds in R. Using 2, we get AB plus AB equal to 0. This is number 3. Since AB belongs to R implies that A plus B belongs to R, ring R, by closure property of addition. This is number 4. Implies that A plus B whole square equal to A plus B, since R is a Boolean ring. Implies that A plus B multiply A plus B equal to A plus B. Implies that by distributive law, A plus B multiply A plus B multiply B equal to A plus B. Implies that A multiply A plus B multiply A plus A multiply B plus B multiply B equal to A plus B. Implies that this is A square plus B multiply A plus A multiply B plus B square. This equal to A plus B. Using 1, A square equal to A plus B multiply A plus A multiply B and B square equal to B. Using 1, this equal to A plus B. Using 1. Then by cancellation law, A cancel and B cancel. B multiply A plus A multiply B equal to 0 by cancellation law. Implies that B multiply A plus A multiply B equal to 0 means here using theory AB plus AB, AB plus AB using theory 0 equal to A multiply B plus A multiply B, this 0 equal to. Now by cancellation law, this and this cancel, right cancellation law implies that B multiply A equal to A multiply B by cancellation law. Implies that A multiply B equal to B multiply A for all A, B belong to Boolean ring R. And this property is commutative property, A multiply B equal to B multiply A. Hence, commutative. Proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.